asked how to find area, not in this year, but in previous years of math, you know how to find area only of a right triangle. Meaning if you have a right angle drop down, then you can find the area. So the area of a right triangle is 1/2 times the base times the height, where the height is the length being dropped down. They'll call it an altitude. An altitude being dropped down that creates the 90-degree angle. So finding the area of this, you would do 1/2 times the base, which is 4, times the centimeters, times the height, which is 2 centimeters, which is what? 8 divided by 2. 4. So it'd be 4, and then do you guys see how we did a centimeter times a centimeter? It'd be a square centimeter, meaning like literally like a square centimeter. Do you guys see what I'm saying? That does not change anything, just saying. That's why a lot of you see centimeter squared and say, do I need to change anything? No, that just means there was 2 things being multiplied together, 2 centimeters. So that literally filled in right here is about 4 square centimeters, like 4 of those 4 square centimeters. Okay, let's find the area here. Area is equal to 1/2 times the base, which is 8 inches, times the height, which is 7 inches. So that'd be 56 divided by 2, which is 28 square inches. Everybody good? Now, here's the thing though. In real life, there are non-right triangles, and you still have to be able to find the area. It is not the same formula. This is the area of a non-right triangle. You need to have it memorized for the test. So it's 1/2 times side 1 times the other side times side 2 times by sine of the angle in between the 2 sides. So you do have to be given 2 sides, and an angle, the angle has to be between the 2 sides. It has to be in that order to find the area. So if not, you either have to hurry and find that, if you can, find the other side or find the angle, and then you can find the area. So 1/2 times side 1 times by side 2 times by sine of the angle in between the given sides. Now guess what? This formula also works for right triangles. So this one always works. So we could have found the area of this by doing 1/2 times side 1, which is 2, times side 2, which is 4, times by sine of the angle in between, sine of 90. You see how that's another way to do it. So I really only use that formula more than I even use the other one. Okay, so let's look at these examples here. If I said, do you find this area? You'd say, okay, well, it's a non-right triangle because there's nothing that says there's a 90-degree angle. So you'd say our area is 1/2 times side 1 times side 2 times by sine of the angle in between. Now notice I'm inputting a degree, so my calculator needs to be in degree mode. Type it in, go. This isn't on your worksheet, by the way. Sorry. So, I can't remember. Everybody type it in and see if we all get the same answer. 1/2 times 14 times 11 times sine of 65. You got 70? Cool. 70 a decimal? Okay, cool. So that's about 70 square inches, right? Okay, cool. Do you guys get the picture? You probably don't need more examples. Now, keep in mind, though, you can't switch it up. Let's say the 65 would have been down here. You couldn't find the area unless you found this angle. And you'd have to find that angle by what's, you'd have to do this with the law of sine, which we haven't learned yet. So we're going to learn enough that in the future, if something happened, you could still find the area because you could continue to solve the triangle. It'll probably be pretty straightforward, yes. So if it says to you in words, guys, just look how easy it is. A triangle has a side length of 15 and 22, and the measure of the angle between them is 95. Find the area. So wouldn't you just go 1/2 times 15 times 22 times by sine of 95? Okay, sweet. Do the ones on the homework. You're going to be doing problems on the back. Problems 28 through 33. Ready, set, go. Should be pretty quick. Now we know how to find area of a non-right triangle. So now we know right now right triangle trig. Right triangle trig allows us to find missing angles of a right triangle and missing side lengths. For example, this is a right triangle. I can just set up simple old right triangle trig to find this side, opposite and hypotenuse. So when I say, oh, this is a sine, right? So I literally say sine of 30 is equal to opposite over hypotenuse. And then we could just solve for x. It's just algebra. So we'd multiply both sides by x, and then we would divide by sine of 30, right? So x is equal to 5 divided by sine of 30. So we're able to use right triangle trig. Oh, heck, another hour of agony. Now, there are non-right triangles, and we still have to be able to find missing sides and missing angles. There are other formulas we can use when you're not dealing with the right triangle, and one of them is using the law of sines. So right here is the law of sines. So start writing it down while you multitask. So first of all, while you're writing it down, they always write angles as capital letters. So this is literally saying sine of angle A, like technically in parentheses. Sine of angle A divided by side A equals sine of angle B divided by side B equals sine of angle C divided by side C. Now we only ever set up 2 of these. So like literally we would just not put this one in. We would say that we would set up this, or we could not put this one in, set up this, or we could not put this one in and set up this. We're not going to use all 3, but they all 3 are equal to each other. So what I also want to point out, you guys, this is really, really important. If this is angle A, the side across from it, straight across, I draw straight across, is side A. So if this is angle C, the side directly across is side C. If this is angle B, this has to be side B. Is everybody good? So the trig ratio is, this is a ratio that is true. Sine of the angle divided by the side across from it. Wouldn't that be true? Sine of angle A divided by the side across from it will be equal to sine of the angle divided by the side across from it. Will be equal to sine of the angle divided by the side across from it. So the law of sines is actually quite easy to remember. Sine of the angle divided by the side across from it will equal sine of another angle divided by that side across from it. Now also keep in mind, we can take and flip these fractions, so this is also true. A over sine of angle A, so I'm flipping it, equals B over sine of angle B is equal to C over sine of angle B. It all just depends on the problem, if you should put the sides on top or the sines on top. It just depends, and I'll explain right here. So, law of sines is one of the tactics, yes. Oh, that's sine of angle C. Good point, Colin. I need to pay attention to what I'm writing, because that's confusing. I read it wrong. Sorry about that. Good point. It has to be the side across from it. You cannot switch this around. It can't be sine of angle A divided by side C. That does not work. So everybody look at this example with me. This is a non-right triangle, and we have to find this side x. So let's set up a true statement. Now, here's the thing. We're finding side x. True? Yeah. I'm going to always start with the unknown. So sides are, I'm going to put the side on top. So I'm going to go like this. X divided by the sine of 40 will be equal to, now I'm going to use this side because I have it. So it's equal to, I've got to stay consistent. I put sides on top in this one. So 5 over the sine of 30. Now look at my truth statement here. Do you see how I only have one unknown? How would I then get x alone using algebra? Good, Elise, multiply both sides by sine of 40. Does everybody see? Just algebra from there. So now look, x is alone. So type in, everybody do it. 5 sine of 40 divided by sine of 30. This is degrees, so you need your calculator to be in degree mode. Everybody should type it in to make sure you can type it in correctly. So what is x? X equals 6.43. Sweet, awesome. Everybody good? Did you all get it? Pretty easy, right? Once you know how to use it. Okay, let's look at this one. Now the algebra is going to come out differently. In this one, we're finding this angle. Good, so we would say sine of that angle. I'm going to erase my work here to have some room to write real quick. So we would now say, okay, the true statement here is, why are we putting sine on top? Because that's what we're trying to find is x. So sine of x divided by, it has to be the side across from it, 8, will be equal to. Now I put sines on top. I've got to stay consistent. So aren't I going to use this angle? So is equal to sine of 40 divided by 10. Now let's use algebra piece by piece to get x alone. What would my first step be? Yes. See, they know algebra. They're just going with their, like, we know that's what we would do with all algebraic equations. So my 8's divide out. So now I have this. Sine of x is equal to all that stuff. Now you'd say, I'm trying to get x alone. It's trapped inside sine. How do we undo that? Sine inverse, I heard someone say. Sine inverse. Isn't that the only way to get x out of sine if it's trapped inside? So So we undo sine inverse, undoes sine. So now finally x can drop out. So over here we have, look, sine inverse, and then what happens with an inverse? Doesn't it eat all that stuff? So sine inverse of 8 sine of 40, that was what was on top, divided by 10. So now you would type into your calculator, sine inverse, so you'll hit second sine, then hit 8 sine of 40 divided by 10. Everybody hit enter and make sure you can get the correct degree measure. You got 30? Yeah. 31 degrees. Guys, let's round to 1 decimal place from here on out. Everybody good? Okay. All right, did everybody get it? Okay, let's do it again. You guys, it's just algebra. It's just algebra. Okay, here we go. Let's look up here at 2 more examples. I'm only going to do 2 more, then you're going to go for it. Sound like a good plan. Okay, so let's say, oh, we're trying to find x. So do you see how Lisa's saying, oh, I'm going to do sine of x then. That's going to go on top, everybody. Sine of the angle. So sine of x over 10 will be equal to sine of 18 over, has to be 12. You can't start switching these around. It has to be sine of the angle divided by the side across from it. Guys, solve for x. Well, what do we do first? Okay, multiply both sides by 10. Then inverse sine both sides. Does everybody see why? To undo sine, because x is trapped inside in this problem. So we'll have sine inverse of all that stuff. So we'd have sine of 18 times 10 all over 12. Go, type it in. I don't think it'll matter that much. Wouldn't hurt. 15 degrees. Is that what everyone got? Hey, let's do one more. Did you know? Are you dividing by 12? Are you hitting? Will you look at his, Macy? Were you getting it? Thanks. Okay, next one. So let's look at this one. You'd say, I'm trying to find a side length. Let's put that on top. Everybody agree? So x over has to be sine of 31 is equal to, we got to stay consistent, 21 over sine of 43. Now guys, it's algebra. So what should I do to get x along? Yep, times by sine of 31. We did not need to take the inverse in this one. Now you'd say, okay, type it into your calculator. So x is equal to. I hear 43? So x is equal to 15.8. Okay, cool. We're going to round to the nearest time, guys. That's 1 decimal place. Okay, here we go. So we don't need more examples, do we? Okay, sweet. What I'm going to have you do then is 15 through 22. Okay, there are going to be times when you're given a story problem, and it's going to be asking you the same information, so I just want to show you a quick one. So this ship is, I'll just give you the basics of it. This ship is lost. They have these spotlighters out there, and the spotlighters have spotted the ship. The spotlighters are 3,020 yards apart. It says, how far is the ship from each spotlight? So I'm going to put a question mark, and then I'm going to put an X, because they're different lengths, right? Just to keep them straight. So let's set up a true statement. So what I want you to notice is, I need this angle, don't I? Well, I can find it because I have 2 angles. So hurry real quick. Do 180 minus 38 minus 57 real quick for me, please. So 180 minus 38 minus 57. Okay, so now I can go ahead and set up the law of sine. So I'm going to say, I'm going to solve for x, so I'm going to put it first. So my true statement is x over sine of 38 will be equal to, I got to stay consistent, 3020 divided by sine of 85. Wouldn't that be true? And then I would multiply up by sine of 38, and boom, I'm done. Aren't I? Yeah. Now, yeah, can I use now Pythagorean theorem to find the other side? I can? No, it's a non-right triangle. Yeah, that one tricks people a lot of times. So you cannot use Pythagorean theorem. Yes, exactly. That's exactly my point here. Yep, now we'll just do it again with the other side. So now we're doing question mark over sine of 57 is equal to, let's just use this again, is equal to 3020 divided by sine of 85. Does that make sense, everybody? We just set up the law of sines again. So then we'd multiply by sine of 57. He's not here. He's on the basketball team. All right, awesome. Okay, let's look at this one. This one gets people every time because there's a little bit more information you have to go through here. So let's see if we can do it. It says, a hot air balloon is observed from 2 points, A and B, on the ground. A and B are 800 feet apart as shown in the diagram. The angle of elevation is 65 and 37 from points A and B. So do you see how, remember, angle of elevation is from the ground up. Do you see how that's my angle of elevation? And then from here is my angle of elevation from point B. Now it asks us to find how far is A up to the air balloon. So wouldn't my x go there? Okay. Yep, that's why it tricks people. Good catch. Good. That angle, they're catching what people make mistakes on. Way to go. So we would need to find this angle. So do 180 minus 65. Okay, good. So now we're good to go, right? Aren't we good to go? Okay, sweet. Because can't I now find that angle? 180 minus 115 minus 37. Can someone tell me that? So this is 28 degrees, and now I'm good to go. So I would say I'm trying to find x. So you'd say x over sine of 37 is equal to, we've got to use 800. So 800 over sine of 28. And now we would just multiply by sine of 37. Okay, good. You guys did not get tricked. Way to go. See, you're awesome. Okay, cool. Okay, now here is, if you can't use the law of sines, you last resort use the law of cosines. So start writing it down. This is how people, it's a lot easier than it looks. So this is how people, other teachers teach the law of cosines with all these A, B, and C's, but people get too caught up in what A, B, and C is. So this is my law of cosines. You're going to hear me say it like this. So it's sine 1 squared, so start writing down the law of cosines. And then I'm going to make some connections. It's actually not that bad. It's actually quite easy. So it's sine 1 squared equals sine 2 squared plus sine 3 squared minus 2 times sine 2 times sine 3 times by cosine of angle 1. Write it down, then I'm going to make some connections. It's not bad as it looks. Couple things. If we have an unknown, we're going to want it on the outsides of the equation. So if I have an x that I'm trying to find a side length, that's what I'm going to call side 1 squared. So I'm going to put the unknowns on the outside. Couple of things to notice. Do you see how side 1 and cosine of angle 1, the outsides have to match up? This has to be the angle that's across from this side. Do you see how the outsides have to match up? Cosine of side 1 and side 1 has to be on the outside. So that's one connection to make here. And then also for the formula, just notice this. So it goes like this. The one of the sides squared plus the other side squared minus 2. It's always minus 2. And then look, it's minus 2 times that times cosine of the angle that's across from that side. So it's actually, you'll see that it's actually quite easy. All right, so let's go ahead and use the law of cosines. Now, I'll show you how would you know when should I use the law of cosines? I'm going to show you. If you try to use the law of sines, you would not have enough information. Look at number 1 on your homework. Here we go. It says find side AB. So AB. Honestly, the easiest way to see if you should use the law of sines or not is to try. So everybody, I'd say, okay, I'm going to see if I can use the law of sines. X over sine of 34 is equal to, but then do you see how we have a 7, we have a 15, but we don't know anything else here. And there's no way for us to find any other angles. So do you see how we would not be able to continue with the law of sines? So you say, okay, law of cosines. We don't know, we don't know this angle and we don't know this angle, right? Those are two angles we have no idea. Do you see how if we set it up 15 over sine of smiley, or 15 over sine of question mark? We have two unknowns in our statement. We don't know the angle, we don't know the side, so we don't have enough information. So we would use the law of cosines. So this is the side we're trying to find. So we're starting there. Side 1 squared, so x squared, is equal to the other side squared. It does not matter which other side you go with first. I'm randomly putting 15 squared. Plus the other side squared, so plus 7 squared. Then it's minus 2. Then it's times that. So times 15 times 7 times by cosine of the angle That's across from the missing side. They got to match up. So cosine of 34. Does everybody see? Now you say, I'm trying to solve for x. How would we get x alone? Square root it, Colton. Way to go with your gut. You know your math. Square root both sides. That is literally, look, root cancels out with power. Haven't we reached our goal? So x is equal to, your ACT will literally leave the answer like that. I even had someone come in with a practice ACT question, this exact question. They said, how would I do this? And I'm like, we have not learned this yet. Sorry, but we will learn it. So that's how they leave the answer. Well, that's easy, because then you don't have to calculate it. We, however, are then going to type it into our calculator once we write that down. Ready, go. Everybody give me a decimal answer. Make sure you can type it in right. I would use some parentheses here. That's a minus sign. Did everybody else get 99.9? Have you square rooted it? Oh, 9.99. Did you get that? Did you forget to square root it?
Yeah.
So you got 9.9. Sweet. 9.9, and then it says round to the nearest tenth. What was after this? So we would round to be at 10. Like that side length is 10. That wasn't that bad, guys. The formula looked harder than it was, wasn't it?
So how do we know just from looking at it that, oh, it's going to be cosine?
We don't. We would try the law of sines, and it wouldn't work, so then we'd go to the law of cosines.
So like, why can't we use like 34?
Because we have two other angles, but this could be 10 degrees. This, we don't know, you know what I mean? Okay. Yeah, let's do another one. Number 2, BC. Here we go. So you say, I'm trying to find this side. Now, once again, if you tried to set up the law, look, if you only have one angle, you're not going to be able to really use, oh, and we're trying to find, well, let's try to set up the law sign. So you say x over sine of 102 is equal to 18 over sine of, oh, still, we don't know. You see how I have to stop? Okay, let's go for the law of cosines. This is the side we're trying to find, so that has to be on the outside. So you'd say x squared is equal to one of the sides squared, so 11 squared, plus the other side squared. Isn't the other side 18? Minus 2 always, and then times that, times by cosine of the angle that's across from that side. So cosine of 102. And you'd say, okay, I need to get x alone. So in this problem, the algebra is telling me to square root both sides. Root cancels out power here, and Colin made a good point. We can't cancel these out because there's a plus sign, right? True, we cannot do that across the plus sign. Okay, ready, go. Calculate that. It says round to the nearest tenth again, so this is 22.96, so it also just, this one happens to round up again to 23. So everybody, number 7. The algebra comes out different. This one says find angle B. So everybody locate angle B, put an X there. That's kind of the easiest way to do it. So I'm going to put an X right here. Now let's go off to the side and see if we can use the law of sines and see that we can't. So we're trying to find that angle. So you say sine of angle X, right, over 28. I'm trying to see if I can use the law of sines equals sine of, we don't know an angle, do we? You see what I'm saying? We cannot continue with the law of sines. Yes. But area is not going to help us find anything. Does that make sense? Because that, I would just be filling it in with dirt. Okay, yeah. Great questions, though. So you say, okay, I've got to find the law of, I've got to use the law of cosines. But this is an angle we're trying to find, not a side length. You can't put that outside. These are side lengths. So we have to go straight across, and that's what has to go on the outside. We got to stay consistent. Our outsides have to match up. Are we going to have cosine of that angle? Yeah, so we're going to need this side to be on the outside of the formula. So you'll do 28 squared is equal to, there's side 1 squared is equal to 1 to the other side squared. So 12 squared plus the other side squared. So plus 18 squared minus 2 times that times the cosine of x trapped inside. So now here's the algebra. We got to be really smart and careful because a lot of people make little algebra mistakes. So everybody, what undoes, we're trying to get x alone. What undoes addition? Subtraction. So can't we subtract 12 squared over? Yeah? So we would have 28 squared minus 12 squared. Get rid of that. Now, plus 18 squared. Can't we subtract 18 squared over? Okay. Minus 18 squared. Now, careful. This is all attached by multiplication signs, isn't it? So we can't add that over. It's attached by multiplication. So I'm going to rewrite what I have so far. So I had, everybody go ahead and calculate that. 28 squared minus 12 squared minus 18 squared. What is that? So we have 316 is equal to, now over here, what I have right now is this, negative 2 times 12 times 18 cosine of x. Now everybody looking, you see how I can't add 2 over? This is all multiplication, right? Can't I calculate what that is though? Okay, do that. So we have 316 is equal to what cosine of x? Negative? Or, okay, negative 4.
Yeah.
432. Yep. Okay. So we have, careful. How do we get that over? Divide. Okay. So you'd say I'm trying to get x alone. So now I'm going to divide both sides by that. So rewrite what you have. We have now 316 divided by negative 432 is equal to cosine of x. Now in this one, how would we get x alone? Good. Cosine inverse both sides. So now you type into your calculator cosine inverse of all that stuff. And that's equal to x. So it's just a little more algebra, but honestly nothing that we can't handle. 137 degrees. Cool. Do you need one more like that? Number 8. Last one that we're going to do together. Sound like a good plan? Here we go. Just find angle A. So let's put an X right there. You say, okay, if I try to set up the law of sines, that would be X over... Nope, that would not be how we'd set it up, would it? It'd be sine of X, wouldn't it? Over 24 is equal to sine of O. Well, can't do it because we don't know any other angles. So here we go. Let's set up the law of cosines. You'd say that's an angle, that's going to be cosine of that angle, so the side across from it has to be on the outside. 24 squared is equal to one of the sides squared, 19 squared, plus the other side squared, 25 squared, minus 2 times that, times by cosine of the angle. Now we can take and subtract 19 squared, subtract 25 squared. 24 squared minus 19 squared minus 25 squared, because we can undo those addition with subtractions. That's equal to negative 2 times 19 times 25 cosine of x. So whatever that is, let's calculate that. You got negative, okay? So that just became, we have negative 410 is equal to, let's calculate that. I also got that. Negative 950, and then we have cosine of x trapped inside cosine. So now we'll divide both sides by negative 950. So we have negative 410 divided by negative 950 equals cosine of x. And then you'd say, to get x alone in this particular problem, I have to inverse both sides because it's trapped inside. So then you type it in and you get angle X, or angle A it was 64.4 degrees. So the algebra is just a little couple more steps. Like I said, nothing you cannot handle for sure. The end of the lesson is there, so you have about 20 minutes to work on this and get as much done as possible.